In 8.3, we're going to introduce vertical stretches and shrinks of our parabolas, but first I'm going to show you what those look like, and then we will get to the formula. Okay, so this first graph of y is y equals x squared. This is the parent function of a quadratic function, and this is normally how it looks: 0, 0, 1, 1, 2, 4, negative 1, 1, negative 2, 4. All of those points are from plugging the x value in. And they're the points that you guys have started to memorize. Okay, now if I graph y equals 2 times x squared, it looks like this parabola. Okay, if you'll notice, it kind of looks like it got stretched taller. We call this a vertical stretch. Stretch. Okay, now this happened because we multiplied by 2 in the front. So all the y values got multiplied by 2. So the 0, 0 stayed the same, but instead of 1, 1, we got 1, 2 because the y value was multiplied by 2. So instead of 1, 1, it became 1, 2. And then up here, we have 2, 8 and negative 2, 8. And again, it's because the y value was multiplied by 2. So the x stayed the same, the y got multiplied by 2. The x stayed the same, the y got multiplied by 2. And because multiplying by 2 makes it taller, it's called a vertical stretch. Okay, now if I look at this graph here, this looks like it got pushed down shorter. So this is what we call a vertical shrink. Vertical is because it's shrunk in the y direction. And that's because there was a half in the front, so it became, the y's all become half as big as they were before. So the 0, 0 stays the same, but instead of 1, 1, it became 1, 1 half, because it's only going half as high as it used to. And instead of 2, 4, it's only 2, 2, because it's half as high as it used to. Okay, so we're going to use this idea of vertical stretch and shrink to change the shape of our parabolas, but we're still going to do our translations the same as we did before. Okay, so now we will officially start the notes for section 8.3, keeping in mind the graphs I just showed you on the previous page. This is called vertex form. This is very similar to what we did last time, where the h moves it to the left or the right, and this can move it up or down, but we're introducing an a value in the front, and this is going to tell you whether there's going to be a vertical stretch or vertical shrink, or if it will maintain the same shape as the regular y equals x squared parent function. Okay, so if the value in front here is bigger than 1, it's gonna stretch it vertically because it's gonna get taller. Now it says absolute value because it could be a negative value here. If it was in negative 2, a negative 3, a negative 4, a negative 5.5, it will also stretch it. It'll just open in the downward direction. Okay, now if this a value, the absolute value of this a value is between 0 and 1, meaning it could be 1 half, 1 fourth, 3 fourths, 2 fifths, it's gonna shrink because it's gonna get smaller. Okay, so we're going to use what we learned about translations previously and to graph these shrunk and stretched graphs. So each of these equations is in vertex form. We're going to identify the translation and describe the vertical stretch or shrink, and then we're going to graph it. We're going to just use 3 points for these. So first, let's do the translation because we did those last time and we're good at those now. So right here, x minus 3 in parentheses will make the vertex move right 3, just like before. The minus 5 at the end is going to move the vertex down 5. And I'm going to go ahead and move the vertex now because that doesn't change. 1, 2, 3, down 5, 1, 2, 3, 4, 5. So the new vertex is going to go down here. And if you're sketching this, just label it 3, negative 5. Here, I'll label it 2 so that on your stretch you know where you got it from. Okay, now I'm going to check and see if there's a vertical stretch or shrink. So I look for the coefficient in front of the parentheses. Okay, this is a 2, so all the y values are going to be multiplied by 2. Because multiplying by 2 makes things bigger, this is a vertical stretch by 2. Okay, now I'm just going to have us graph one extra point. So normally when we do the parent function, we go right 1, up 1, right 1, up 1. But because it's a vertical stretch in the y direction, I'm going to go up 2 instead of up 1. So I'm still going to go right 1, but in the y direction, I'm going to go up 2. And that's going to give me a new point there. And then in the x is negative 1, instead of going up 1, I'm going to go up 2 because I'm going up twice as high as we normally do. I could do another pair of points as well, but for this year, I think 3 points will be good enough. Okay, I'm going to go ahead and sketch my graph. Okay, and this is a good sketch of what my parabola should look like. And it did open up because this was positive in the front. Let's go ahead and try the next one. Again, I'm going to start off with the translations because they will tell me where to put the vertex. Since this is x plus 1, this is going to move the vertex left 1. And then because there's a minus 3 at the end, the vertex will move down 3. And I'm going to go ahead and plot that point. See, left 1, down 3 puts the vertex here. And if you're sketching, go ahead and label it. Okay, now let me just see if there's any kind of stretch or shrink. Okay, if I check the coefficient, there's a 2, and it's positive, so it's going to open up. So it's going to vertical stretch by 2. And it's vertical because it only affects the y value. Okay, so instead of going 1, 1, 1, 1, I'm going to go 1, but I'm going to go up 2. So I go twice as high, and that's going to be good enough for a stretch. And it does look like kind of tall and skinny parabola. Okay, let's mix it up a little and do a few more. And if you're sketching it, just try to make it look like it's going up 2 on each side so I know that you're respecting this stretch. Okay, see, let's check. Let's see, first let's see the translation. Left 4, up 1. I'm going to go ahead and replot my vertex. 1, 2, 3, 4, up 1. Okay, I'm going to label it just because if you don't have graph paper, you want to make sure you know where it came from. Okay, let me check for a stretch. Oh, it's a negative 2. Now, the negative just means it's going to open down. So I'm going to keep that in mind. The 2 tells me it's going to be a vertical stretch by 2, but it has to go in the down direction. Okay, so I'm going to go to the side 1, and I want to stretch by 2, but I want to go down. So I'm going to go down 2. On the left side, left 1, down 2. And because I said you only had to include 3 points, this is good enough for a stretch. It's opening downwards, and it looks like it got stretched or it got skinnier. Let's look at the next one. First, let's check the translations. X minus 2 in parentheses means right 2. Minus 1 at the end, down 1. So I'm going to plot my vertex, right 2, down 1, down here. Okay, let's see, is there a stretch? There is. There's a number in the front. So 3 is actually going to make it 3 times as tall. So this is a vertical stretch by 3, and it's a positive 3, so it's going to open up. So I'm going to go this side 1, and this time I'm going to go up 3 because it's going to go 3 times as tall as normal. And then same on the left side, left 1, up 3 because it goes 3 times as tall as normal. Okay, so this is an extra stretched out graph, which means it's extra skinny and extra tall. Okay, let's do a couple with the shrink. Then we'll practice. Okay, first let me check my vertex. X minus 2 in parentheses means right 2. The plus 3 at the end moves my vertex up 3. Okay, now let's check for a stretch or a shrink. Okay, it's actually 1/2. Now, if I'm going to make it half as tall, it's going to shrink. It's a vertical shrink, and the factor of the shrink is 1/2. This one's a little bit tricky to graph. It's a positive, so it's going to open in the positive direction. So instead of going to the right 1, up 1, I'm still going to go to the right 1, but I only want to go up halfway, which puts me right in the middle. On the left, I'm going to go left 1, but in the y direction, I'm only going to go up half. So about there. And I know it's a little hard to sketch, but let me sketch it out. It's going to be kind of wide because when it's a vertical shrink, it ends up being a wider parabola. And then that's a good sketch. Those 3 points will be enough. Okay, one more. Okay, let's look in the parentheses. X plus 5, vertex moves left 5. There's no vertical translation because there's nothing at the end. So left 5, 1, 2, 3, 4. So my vertex is at negative 5, 0. Let's see, I have a negative 1/2 here. The negative just tells me it's going to open down. I don't have to write it because it didn't ask, but just keep it in mind. The vertical shrink by a factor of half. Okay, so I'm going to go right 1, and normally I would go down 1, but because it's a half, I only go half the way, which means I end up right in between. Then on the other side, same. Left 1. Normally I would go all the way 1, but I'm only going to go halfway. puts me right here. Okay, I'm going to do my best to sketch it, and it's kind of wide because when it's a vertical shrink, it ends up making it look like a wider parabola.